Okay. Good morning, everybody. Thanks for joining us. We're going to do a 20-minute webinar here on hyperconvergence and kind of CEC story as we worked our way through the years towards this solution. So joining us today is Steve Foley. And as you can see on the screen, he's a seasoned vet in the IT world. He joined the CEC team in 2010. I put 20 plus years of IT experience. We won't say how many more than 20. We don't want to give anybody's age away, right? And let's just say he's been in IT for a while. He kind of specializes on the server storage, virtualization, and backup front. The other side of that, really the key other side to that piece is network. But Steve really holds up that infrastructure side for us. I wouldn't exactly say he's our systems administrator, kind of have a shared responsibility amongst our group there. But I think the phrase that we really liked was technical advisor for the CEC internal systems. He also has the customer-facing role of systems engineer for us as well. So designs systems, consults with customers on any of their storage, server, virtualization, and backup needs. Also kind of works with endpoint protection, or commonly called antivirus, right? But goes a little deeper than that. I'm Jim Anderson. I'm the Network Infrastructure and AV General Manager. I joined CEC in 2015. My prior experience is mostly in IT. On the higher education, K-12, and government front is so what we call SLED. Also 20 plus years of IT experience, kind of started when I was, in my college days, and kind of worked my way up from a help desk position to where I am today. My role is primarily vision and strategy for all three of these technologies, AV, IT, and structured cabling. I'm an advisor for CEC's internal system, but I put the little $ there because I'm more of the financial advisor. So I have CapEx budget responsibilities, and I use Steve's knowledge and experience to kind of help build the plan that we're going to roll out. My key responsibility, as it's customer facing, is to facilitate the relationships with customers and what we call partners, which are manufacturers of the various products, because really CEC doesn't make anything. We don't have an assembly line or a manufacturing facility anywhere. We simply resell products, but offer our expertise and service and implementation for those products. CEC, for anybody who's not familiar with everything about us, we serve 7 markets in 8 office locations. Those 8 office locations are Hiawatha, Davenport, Dubuque, Waterloo, De Pere, Madison, and Milwaukee. And for anybody that's not familiar with Iowa, Hiawatha is in the Cedar Rapids metro area. And anybody that's not familiar with Wisconsin, De Pere is in the Green Bay area, metro area. You can see on that blue band on the bottom that these are our primary technologies, with one exception: healthcare. We kind of wrestle healthcare as both a vertical and a technology because of the healthcare systems that we provide. So AV, IT, structured cable, I am the general manager of those 3 technologies. Fire and security, two-way radio, there's another gentleman who's the general manager of that. And then there's a third general manager of healthcare solutions. So I think that's a pretty good introduction. With that, we're going to jump into kind of like a timeline of how CEC is dealing with this server storage, virtualization, and backup evolution. Take it away, Steve.
Okay, so yeah, again, this is Steve Foley. So in 2010, when I started at CEC, it was mostly physical servers in the environment. So there were multiple racks in the data center, and they did have a couple of VMware hosts, but kind of a siloed type approach, each individually managed. So when I got here, we started virtualizing some servers. Instead of buying another physical host, we would, hey, let's just virtualize this thing. So that's what we did. And then there's other servers where we used a VMware converter like P2V, and turned a physical server into a virtual machine. We implemented Veeam to back up those virtual machines, and basically, started on the path of virtualization. So a year later or so, we added another host. We upgraded our VMware licensing. We added a vCenter machine, and now we're able to do vMotion, and I left out a part there. We added a small SAN for shared storage. So now we're able to do vMotion. We added some high availability capability there. And now our solution is getting complex, right? So you have iSCSI connectivity to the SAN. You've got the configuration of LUNs and data stores. You have network redundancy, multiple NICs in multiple hosts connected to multiple switches. Same thing on the SAN, multiple NICs connected to multiple switches. So you're trying to build out some redundancy there, right? There's a VLAN for storage network. And then at this point, we started virtualizing some more things. We virtualized our Exchange server and, some other servers, and we're well on our way. So we've got a SAN with 4 terabytes of storage at this point, like I said, a small SAN. So we get to 2012, we add Unitrends as an appliance. We back up our virtual machines with, this great Unitrends appliance. We replicate that to the cloud. Unitrends ends up replacing our Veeam solution that we were using. We go to 2013 or so. We upgrade our SAN. We needed more space because we started virtualizing a bunch more machines. So we upgrade that SAN. Network switches, I believe, were upgraded around this time. There's 10 gig connectivity. And again, we go through the complexity of configuring all of this stuff, getting the host to connect to this new SAN. Again, it's iSCSI connectivity and, creating LUNs and that sort of thing on the SAN. So we get to about 2015. We started to take a look at this environment, and we're realizing that this is where all of our virtual machines are running, right? Everything's in kind of one basket here. So we want to build in some redundancy, and we're planning for some replication. So additional resources are purchased. So we decided to go with a couple of new servers in our DR site, a couple of new servers in our data center. We've got 2 SANs that we're going to purchase. So we'll have one SAN in each location, and eventually we'll have replication between those 2 SANs. So, pretty big purchase here, but, we're building this out so that, something happens to our data center. Hey, we can run everything off this DR site, right? So, the problem with some of this stuff is, okay, big purchase, and you're trying to plan for, let's say 2, 3, maybe 4 years down the road. So how much storage do we need? How many CPUs do we need? How many cores, how much memory, all that stuff. So you're trying to plan and purchase it all now, right? So you're planning for the future, you're buying something that you're going to use right away that is probably way more than you need, in hopes of, I guess basically growing into it and maybe having the right amount of resources there on the back end, right? So anyway, so there's a lot of complexity to this solution. We, again, there's multiple switches, multiple NICs, multiple SANs. There's configuration of multiple data stores on all these vSphere hosts. So we had this great virtual environment, right? So we have all kinds of disk space. We've got all kinds of resources. We've got a bunch of CPU. We're pretty much ready. So anytime a department needs a server, hey, pretty easy to spin one up, provision a server, and hey, here, basically get it ready and hand it off to, whichever department needs that server, right? So easy. So the environment's growing, and things seem fine, until we hit about 2018.
Sure.
Started adding too many servers. So
yeah, and then this was a kind of an important part of CEC's history right here. We changed CRMs, and so we'd been operating on the same CRM for approximately 4 or 5 years. just kind of upgrading in place. And then we discovered, we were doing a lot of customization to that CRM, and it was starting to not fit our needs. And so we needed to make a transition to a new one. And so we make that transition, and that's all good and great. And if you remember, kind of our last big landmark was back in 2015. And as Steve mentioned, as I initially mentioned, I'm the guy, the money man, right, for IT. And so I start talking with the CFO. I'm getting a little concerned now because, as Steve mentioned, the ease of virtualizing a server has started to kind of create some issues for us. And so now we go and we order this new line of business application that's critical to our needs, and it's underperforming because we've got too many resources tied to this this server storage configuration that we had put together back in 2015. So we realize we've got a spinning disk versus solid state disk issue. We quite frankly need a different solution at this point, and we start to kind of look into that.
Right. So, we look at this, we're looking into it. CPU and memory are fine on the servers, right? So, okay there. Turns out being, like Jim said, it's disk contention. So we have too many virtual machines contending for disk time. So, we're hearing complaints about this new CRM. It's slow, it's whatever. Hey, what can we do about it? So we start looking into some short-term fixes, knowing that at some point we need to have a long-term fix, but let's fix this quickly. So get things, making the users happy and get the CRM working better. So what we ended up doing is we purchased some solid state drives. We installed them on our local vSphere hosts. We moved these new CRM servers and some other critical machines off of that spinning disk, off that SAN, onto these solid state drives. So that sped things up, that twofold. It made everything that moved to solid state quicker. It also took some of the load off of the SAN. So there's our short-term fix, right? So now, okay, what do we do next? So some of the things we looked at were adding another shelf to these SANs, maybe a solid state drive shelf, more of a hybrid type solution there. Servers were not really the issue. So I think we're fine there. CPU and memory usage was low, or do we replace that SAN entirely? One thing we started looking at was, converged solutions and hyperconvergence. So basically, we started looking at hyperconvergence. So hyperconvergence is a tightly integrated system that combines server, storage, that natively includes the hypervisor, right? So everything's tightly integrated. So we started looking down that route for a couple of reasons here. We showed this complexity before, right? So there's a slide here, the inverted pyramid of doom. That's basically what you end up with. You have multiple hosts connected to multiple servers. There's multiple, at this point, multiple data stores. There's a management server. There's a lot of stuff to configure and manage. So not only do you have to manage a VMware environment, you have to be able to manage a SAN. So one of these things we wanted to look at was something less complex, something that more people in our organization could help manage, right? So what we started looking at was hyperconvergence, and we wanted to get away from maybe some of the VMware licensing and maybe the support subscriptions and things like that. So you start looking at this, and how nice would it be not to have to manage two systems, a SAN and a vSphere environment, right? It's multiple servers, and then not having something that looked like the inverted pyramid of doom here. So we start looking into this. We saw demos on HCI, hyperconverged, from basically all the major vendors. And, we figured that was probably the way to go, but, it's pricey, right? And then how do you choose? Which one do you choose, right? So after more research, we heard from, I guess, friends of CEC, maybe a former employee working somewhere else, told us about a solution that they had implemented. So they made some introductions, and we saw a demo, met with the sales team, heard more about the company and the solutions. I saw a demo. I think Jim did too initially. And I loved what I saw, and I just said, hey, let's show this to some other guys, right? So the rest of our team. So we set up a demo, and I remember sitting in the conference room for this demo, and I can just see everybody just, like, wow, this is cool, right? So like me, they loved what they saw. So they love this hypercore operating system, basically KVM based. Checks a box, hey, vSphere and Hyper-V, not required. Nice. All the features are available right out of the box. No extra licensing is required, unlike some of the other ones that we have seen. Much easier to manage. There's no management server or PC required, which was a plus, right? Provisioning a virtual machine required about 4 mouse clicks and typing in a virtual machine name. That was pretty awesome. Then we started hearing about non-disruptive scale out. When a cluster needs more resources, simply and easily add another one. The other thing was mix and match those nodes. Some of these solutions we're looking at, if you wanted to add another node, that node had to be the exact same size as what you currently have as the other nodes, right? So this one, mix and match. You need more memory in this next node, you can add it. Doesn't matter. And then, it has this non-disruptive rolling updates. Okay, that's pretty cool. One node needs to be upgraded. Actually, the whole cluster needs to be updated. The virtual machines get moved from whichever node is being upgraded to the other nodes and on down the line until that upgrade is complete. So no downtime. That's pretty cool. So, we're hearing all these great things and liked what we saw. So we saw how easy it would be to replicate this cluster to a single node. That checked a box. Hey, that helps out with our DR. That'd be pretty awesome. So really what we're looking for is something that's easy to manage, less complexity, and, easy to scale out. So, it comes down to ease of management, staffing, doing more with less. We don't need somebody to actually, I wouldn't say babysit, but manage 2 different systems at this point, right? So I think everybody liked what they saw. So I ended up working with a sales engineer, and we installed a utility called Live Optics that gathered performance information from our current environment. And the SE used this Live Optics data for sizing out a new solution for us. So we're showing a couple of different options. One's with solid state drives and, all flash, and then another one that was a hybrid solution. And basically we ended up going with this hybrid solution. We budgeted for a 3-node hybrid cluster, which is a mix of solid state drives and spinning disks, for phase 1 of our plan here. Phase 2 would consist of adding a replication target a little bit later down the line.
Yeah. So that was the plan, and you know what they say about the best laid plans. So on August 10th, we experienced something that Iowa has never seen before, to my knowledge, and that was a derecho. In fact, we didn't even know that this was a natural disaster. And prior to this, our favorite one to reference was a Sharknado, right? And we thought, anything can happen. This stuff is ridiculous. We'd already been experiencing a natural disaster in a way due to the COVID-19 epidemic and the way that pandemic, that changed the way we worked. But this, quite frankly, we had 5 Iowa locations, as I mentioned, and this brought 3 of them to their knees, in the sense of there was no communication even with the people in those locations, because there was no internet and no cell phone connectivity. So here we have our main method of storage, server, virtualization contained in one of those offices that has no power. And our backup location we plan to do in December of 2020. So we were not in a great position to be able to bring our systems back up and make them usable. Because I mentioned we have 3 Wisconsin locations that basically in the 1 minute everything's working fine, the next minute they have access to nothing. And so as far as they were concerned, it was business as usual, even though here in Iowa we were struggling. So we didn't get to kind of implement our second phase, which would have been, a great way to respond to this type of problem. So we had some options. We could keep it where it was at and try and restore power, but then we had the internet issue, right? Not having any network traffic flowing from outside of our firewall. So one option we had was to load up this, this piece of equipment, this 3-node cluster, travel to Madison and set it up there and get it going. So at least, you know, the people that had internet at home or in Wisconsin, they could get to our systems and everything would be fine. Instead, we go to Cedar Rapids, a few of us from Dubuque who didn't get hit as hard. We show up with generators and gasoline, and lo and behold, we had network connection. So we kept those generators going kind of around the clock until power was restored and we were able to go. Now, Steve, you probably take this one, our decision next after we survived derecho.
Yeah, so, you know, the decision is, okay, we want to put this replication node someplace, right? So do we do it ourselves? Do we move it to a co-location site? That, you know, I guess various factors were weighed. You know, we had a location in Wisconsin that could house this, so we ended up going down that route. So we ended up installing this node, one of our other offices, and we were able to get a replication going in a matter of minutes. I mean, it's one of these things. Well, after that node is up and running, it's a few clicks on the host side, not the target side, but the host side. You add the replication node, a couple clicks, and it's ready. It sees the target. And then as far as replicating VMs from there, again, it's another couple clicks, and then obviously there's some time waiting there for things to get replicated and synced up. So it really probably takes more time to actually rack this unit than it does actually set up, which is pretty cool.
So now we go, you know, we survived this derecho. We expedited the replication unit that we moved to a Wisconsin office location to give us the furthest spread, since we know that this natural disaster we just incurred went from South Dakota to Ohio. You know, we gave it the furthest distance we possibly could. So where do we go from now in terms of trying to prepare for the future? We decided that we were going to add a node a year. And Steve mentioned before, since they don't have to all be the same size and configuration, this makes it easier to scale out. So in 2020, we have our cluster in Cedar Rapids. We've got our node in Wisconsin. We've got our primary backup in Cedar Rapids and our redundant backup in Dubuque. In 2021, we add a node. So we take one of the nodes out of the cluster in Cedar Rapids. We move it to the Wisconsin location. Now we have our cluster, and our redundant nodes are a set of 2 nodes up in Wisconsin. Keep our primary backup in Cedar Rapids, our redundant backup at another location in Iowa. Then we go to 2022, we add yet another node. Now we've got our cluster built in Cedar Rapids, and now we officially have a redundant cluster built in our Wisconsin location, our redundant location. We take a look at resizing our backup at this point because we've probably grown to the point where we need to do that. We take the new backup unit, we put it in Cedar Rapids. We take the old backup unit in Cedar Rapids, we move it to the other location in Iowa. And then in 2023, when we add a node, we've officially retired all of our original nodes in the first cluster we bought late 2019, early 2020. I want to, we'll end here. It's going to be a 25 minutes of tech, but we have Scale Computing is going to do a follow-up webinar next week on the 9th. Here's the information on it. The 9th, it's at 10 o'clock, I believe. And Jared Pexa is pictured there at the right. He's been a really great systems engineer for us to work with. I hope this was helpful for you guys. We are by no means perfect, so we figured we would share our timeline, which I figure is a lot like most of yours, except maybe the end where we chose a hyper-converged infrastructure. So with that, I want to thank you all for joining, and we hope you enjoyed the topic, and we hope you join us next week. Thanks, everybody.